So we all know about database management systems, right? So we all know how the query is processed and how the query is evaluated in database management systems, right? So have you ever had a question like how the query is evaluating in large databases and then how the query is processing in large databases? Is it time taking? And then is it, I mean, how the whole process has been done? So if you have the same doubts, we are in the same page, guys. So I had this doubt for a long time. So I've been searching for the right, um, right material. So then I came across the research paper called Query Evaluation Techniques for Large Databases. Okay. So before going to the introduction part, I wanted to tell you what's the problem the research paper is talking about. Okay. So how, I mean, we all know the if we have a thousands of rows, if we write a query, on that particular table, it will take some time to generate an output. So then, what about uh, thousands of tables which consist of billions of rows and billions of data? So all those things will be if we in this research paper we came to know all the answers for that. Okay, the problem definition, I mean the it what in the research paper it's discussed about how we evaluate the queries for large databases. Okay, so now we come to the introduction. So effective operation of large volumes is necessary in nearly all computer operations, from business data processing to library information reclamation systems, right? So everywhere, if you know the Instagram page, right? So can you able to imagine how the database for Instagram will like? So there are crores of people using, not a crores, not billions of people using Instagram. So then how the database for Instagram be processing, how the queries are processing in the Instagram database, right? So every app, basically everything needs a database which stores information of users or any particular confidential information of a company, users, and everyone. Okay, so so basically, everything needs a database. Okay, basically the large data volumes of database. So while database operation systems are standard tools in business data processing, they are only slightly being introduced to all the other spanning database operation system. So in the previous years, whenever these guys, the researchers are talking about storing a large volumes of data, there have been contradictions between researchers, like whether they can use parallel database system or some other methods. So what are, I mean, what they have been discovered lately, we'll be seeing in this research paper. Okay, basically at first, database operating systems have not been used for two reasons. First thing is the restrictive data description and manipulation languages can make operation development and conservation unbearably clumsy. So, research into semantic and object-acquainted data models and into patient database programming language has been addressed this problem and ultimately lead to the respectable results. And then the second reason is like data volumes might be so large or complex that the real or perceived performance advantage of train systems is considered more important than all the criteria. And also, basically, in the basic thing, how the query is processed in a database system. You can see the number one point like user interface, right? So this is a user interface where we use a command prompt or where SQL, Oracle will write the queries in that. Okay. So how database query language? We all know relational algebra, right? Relational database, right? So there we'll be having some symbols, how the computer can understand, how the computer can understand the language of a database, so it will convert into that and the query got optimized, and then it got processed in the back end and the output will be given to the user. So it happens in a seconds of time. So this is another flowchart of how the execution happens. Parsing, okay, and then query validation, view resolution, optimization, and then plan compilation and execution. Parsing is nothing but we all know compiler, right? What compiler does or interpreter does, it changes a basic high-end language to the computer understandable language, right? So that how the parsing works in our database. So parsing will do will analyze the human human language to do computer understandable knowledge of a database. So and then it will get validated. So if the query got validated, then the view resolution will be happening. So after that, the optimization part. So here comes the big deal. Okay, so whatever the small query or a big query, everything it will force here. When it comes to optimization, it may differ. I'll tell you how, okay? And then it runs the compilation and it will execute the query. So I'll just briefly explain here, okay? After a query or request has been entered database system, be it interactively or by an application program. Like interactively in the sense, we'll just write a query based on some application program in the sense we all know login page, right? So whenever we give username, the password pops. Whenever we save that, that saves into a database. Whenever the application got rendered, so if we enter a username, the password it says a password automatically. So that's how the application program uh, is been communicated with the database system. So the query is passed into an internal form. So the next the query is validated. Again is the metadata to ensure that the query contains only valid references to the existing database objects. So if that database system provides a macro facility such as relational views or referenced macros and views are expanded into the query. So integrity constraints might be expressed as views and would be integrated into the query at this point in most systems. So the query optimizer then maps and expanded query expression into an optimized plan that operates directly into the stored database objects. We already discussed about the problem definition, right? So now we're gonna see proposed approaches often authored in the research paper. So how to how to evaluate queries for larger databases, okay? So before discussing that specific algorithms, two general approaches to managing sets of data are introduced. So the purpose of many query processing algorithms is to perform some kind of matching, bringing items that are alike together and performing some operations on them. So we all know alike operations, right? So whenever there is a similar kind of a data, if we write a query on only on single line based on alike operations, it works on the similar data and then the data will be manipulated. So there are two basic approaches for such value based operations. One using pre-computed data structures using as indices and the other using large amounts of memory. So the memory based algorithms can be further divided into the based on sorting and those based on hashing. So here comes the point. These are the two methods which we're going to use for large databases to optimize a query. That's how we evaluate a query. Okay, this pair sorting and hashing permits many aspects of query processing from indexing and clustering over aggregation and join algorithms to methods for parallelizing database operation. Therefore, we first discuss these approaches first in general terms without regard to specific algorithms. So, and then in the sorting, we have the most commonly used sorting methods are merge sort. We all know, which is discussed in data structures. We all know that's being discussed in data structures, right? And also B plus T, right? A single buffering tree and then double buffering tree. I'll show you what is that. Here you can see a B plus tree. So basically, in data structures, I'll just give you a high-end knowledge of B plus trees. Okay, so whatever the root node is fixed, so left side and right side of nodes will be like left side will be ascending, will be lesser than the leaf node, and the right side will be greater than the root node. Okay, so based on that logic, the B plus trees is being divided, is being sorted. Okay. So here you can see index direct search, right? So here, if we assume it's like 90. So if we want to insert an 80, so where we gonna insert it? Here. Because it has to be 80 is a less than 90, so will be insert here. Okay. And then this is also a left side node, right? So what if 85 we need to insert? So it would be inserted here. So that's how sorting sorting works with the B plus trees. So you know we have a large number of database. I mean, a large number of rows in a table. If we write a query, just assume it's billions of rows in a table. So we need to do ascending, or we need to you know uh, we need to get the people who are from a lesser age to a bigger age. So it has to sort, right? So if it not if the database it, if think it's not using this sorting method, so then it may take lots of time to execute. Okay, so basically for instance, if we have 10 to 40 age people in that particular thing. So 10 to 40, what's a 40 we'll take a mean of that. 40 plus 50 is 40 plus 10 is 50 by 2 is 25. So the root node is 25. So before root node and after the root node. So the time complexity will be lesser. Okay, so like that, the B plus trees use for database in sorting methods. Here, the first buffering method, okay, one buffering method. Here, assume this is the database and this is one of the database. Here, I mean, this is an input, or this, let's assume this is an input or this is an output, okay? In the input, we have given a big query. This memory buffers, I mean, in one buffering method, what it does, like a subqueries, it will be divided like a n minus 1 inputs, and then it will process first. It see, basically if it not divided, then the query gonna take 30 to 40 minutes to execute. Like it has to check each and everything for every domain, right? So but here, if it is divided as a subquery, this subquery does that part, this subquery does that part, whatever that been checking in the database. So if every output is ready for each input, if we combine all those output, then whatever we desired output comes here. Okay, like that. It's been basically it's a divide and conquer formula. I mean, you remember like a merge sort, quick sort, everything. Like that it works. And then this is double buffering method. So maybe the two subqueries are working for one part, and two subqueries should work for one part, and two subqueries should work for one part. Then we need to we can use this double buffering method, same as a single buffering method, but this one two subqueries works on a single time. So two subqueries works on single time, like whatever that subquery is defined to, uh, they, those will work, and then it will combinedly give a two outputs, like how many partitions were there. So all those partitions outputs will be coming here, and then all combinedly they will give a output. So like that, the time complexity even more decreases using this. So what are the contributions does the author gave in this research paper? So he gave an ideas how the machine evaluate the queries for larger databases in spite of all the challenges. Now, one challenge may be we can assume that maybe that may be the time taking process, but he gave some nice methods where the time complexity decreases and and the query works efficiently well. And validation. So whatever the author has described is legit, and not only that, we use sorting methods in data structures as well. So in that also, it is used to process the program in lesser time, basically for the optimized version. But you remember, so here I told about the optimization, right? So in that process, all these methods will be worked. And these are the papers you can take a reference. Thank you so much.